So yeah, so Jason's aunt usually comes, who's that? Oh boy, I'll have to read that later. Jason's aunt comes down every year for Dragon Con, and we usually go and visit with her because she's in town, and that's really cool. But we used to go down for the parade, and we don't do that anymore because it's gotten insane. Like parking and everything else is just kind of ridiculous at this point. But we do go down and we breeze through the hotels and look at all the funky costumes, and then we usually go like we used to go to the vendor hall, but you can't get in unless you have like the pass. So she would loan us a pass, and we'd go in and look at all the stuff. But now they've moved it like to another building, and it's this huge big thing, and the line wrapped around the block. And I said, you know, there's nothing I want to buy that much. And it was on the western side of the building, and it was Sunday afternoon, so the sun was beating down on these people standing in line trying to get in to buy weird stuff. And I was like, you know, I love weird stuff, but that's just too much for me. I'm not gonna stand for that. All right, so this was the last of the lessons that I had to write for you, right? After this, what's your next lesson look like? If you flip to lesson 5, tell me what that looks like. I want to be sure that y'all know what's coming here. Speed. Yep, measuring speed. And what does it say for the assignment?
Mine has lesson 5.
Mm-hmm. Yeah, so what's lesson 5 say? What are the assignments for 5? What's it say to do?
I'll read textbook chapters, sections,
textbook.
9.1, 9.2.
Dun, dun, dun. Textbook. Okay, so once you get into the textbook, I'm going to open this up because Sky's not here yet, this way she can look at it. So lesson 5, if you go to the Dropbox link, which you can access through the website, and we have it in the forums, and I've also put an individual link for each file in Teacher Ease for your assignment. There is an audio file for every single chapter or lesson we're reading in the book. It's nothing additional. So if you are comfortable just reading the textbook and you feel like you can get the most out of the lesson by reading it, go right ahead and read it. You're not going to miss anything by not choosing the audio file. But if you feel like you get more out of a lesson if you hear it and try and read along, or you know, if the reading is stressful to you or it's just not your strongest point, then go ahead and listen to the audio file. But you really should have your book with you, because there are pictures in your book, illustrations and graphics and things like that that are important to see. And it's really good to listen and then follow along, right? Even if you know that you're hearing everything, it's still good to follow along word for word. So it's a good thing because you can like put it on, you could listen to it on a smart device, or you could probably even, I think you can download it like to an iPod or something, and you could sit in the car and, you know, flip through the book while your mom's driving you somewhere and listen to the lesson. And from here on out, the lessons get, well, like I explained it to the older group. The first 4 lessons were the review of earth science and the whole what is science thing, right? Like we had what is science, and we had like 3 lessons on earth science. And basically those were covering a broad amount of material in a small space of time. So now what we're going to be doing is we're going to be covering a smaller amount of material in a larger space of time. So the notes are going to get smaller, but we're going to get more involved, more detailed. Lots of detail. We're going to really hash out the stuff and make sure you totally understand it. Whereas the earth science was like a high-level overview. Does that make sense? Yeah. Okay. There's high-level overview, and then there's like, let's get nitty-gritty. It becomes more nitty-gritty. But the audio file, for example, it's going to look like, if you go to the Dropbox, it's going to, it's going to look like that. And then once you click it, it's just me reading. And occasionally I might say something like, let's pause for a second and look at that picture, you know, but I don't give any extra. Okay, good. So if you're good with reading, you got it. Nothing different there. All right, so let's look at our notes. So today's lab should really reinforce some of this. You guys are probably pretty familiar with the solar system anyway, right? Yeah. All right, so what I'm going to try to do with today's lab is give you guys a perspective on how big the solar system is. And then the crazy thing is, I want you to look sometime between now and when you leave. I put a poster on this door.
Do I have to turn this in?
No, that's what you're looking at right now. Okay? That's what we're looking at. Those are our notes. Because that is a picture of the galaxy. And it shows where we are in the galaxy. Like we're a tiny little dot in the galaxy. And then the universe is even bigger than that, right? So it gives you some perspective on just how small we are in the scheme of things, right? All right, so let's look. So it talks a lot about our moon too. Our moon's cool. So somebody tell me about these two early scientists that we mentioned in our reading. Who were they, and what did they think about the way our solar system is set up? Anybody go ahead, Drew.
One thing I did notice about it
Mm-hmm.
is how, well, I don't really think this would be like an accurate representation of what it would actually look like,
Mm-hmm.
because of how big the sun is and how small the earth is.
Yeah.
The earth is maybe like 2 suns away,
Yeah.
which means
Uh-huh.
we would be like dead.
Yeah, we would be. Yeah. So you're saying that the scale.
Yeah, it's really
But which model are you looking at? There's two models there. Which
both
one?
of them.
Both of them, yeah. Which one are you talking about? Where? Okay, well, both of them. Yeah, I guess you're right. So, can anybody tell me about the two different scientists and their two different models? Jack?
One was Ptolemy, and he thought that the Earth was the center of everything. The
Right.
Earth was, I always say it's a star because the sun's a star.
Yeah, that's kind of what they thought. Yeah, the Earth was at the middle. Mm-hmm.
It's like the star of the show,
Yep.
and everything revolves around it. But the heliocentric theory is that the sun actually is the star.
Is at the middle, right? Very good. All right, so this dude Ptolemy, right? Where was he from?
Egypt.
There you go. He was Egyptian, right? And a lot of the times when we talk about science, we hear a lot about European scientists, and that just kind of comes from our perspective of how knowledge got passed along through written word, through sort of the dominant culture. But this guy was Egyptian, not European, and he's super, super important because he was the first person to kind of draw like a model of the solar system. And what did people think of it at that time? Of Ptolemy's model with the Earth at the center. Did people think he was right?
Yeah.
No, they totally believed him. They're like, yeah, this is the way it is, of course.
He's the only person who has shown them
Yeah.
what the solar system looks like.
Exactly. So when you see that word geocentric, that's your first blank, right? Geocentric. All right, I'm gonna write that. Why did I put my, here it is. All right. Those note words. We talk about Latin roots, how there are a lot of Latin, and there's Greek too. There's a lot of Latin in science and Greek. But this is an important word. You've seen this before somewhere, anywhere. Where have you seen that?
Geologist.
Geologist, yeah, what else?
A geode.
Geode, yep. What else?
Geocaching.
Geocaching, that's a good one. I love that one.
Geodude.
Geometry dash.
Geometry dash. I love it. Yeah, okay. All right, so what do you think it means then?
Like the earth.
Earth. Okay, very good. That means Earth, all right? So when you see this, it means Earth. So this is a real easy one. When you see either, it's usually ology. Whoop. It's usually ology, but in this case, there was already an EO. Anytime you see this, do you know what that means? Anybody know what that one means? Do you know?
Geologist.
Yeah, that's geology, but what is ology? Does anybody know? Do you know?
Is it like a study of?
Yes, the study of, perfect. That's exactly what it means. The study of, right? Whoop, that's a messy Y. All right, so what if I wrote, this is a good one that you might know the first root for. There's so many ologies. Okay.
Biology.
What is that?
Study of life.
Yes, because this means life, right? Perfect. Study of life, right? So geology means the study of Earth, right? So you see how that works? The study of life, the study of Earth. You can think of lots of ologies. Physiology.
Zoology.
Zoology is the study of animals. Psychology. There's a good one. Anybody know that one?
Entomology?
Mm-hmm.
I heard of it,
It's
but I
the
forget.
study of insects. How about this one?
Doesn't that count as an animal?
Yeah, but it's a type of zoology. How about that one?
Oh, brain.
Yeah, neurology, right? There's neuro study of the brain. All right, so that's Earth. All right, and we know that ology is study of. So this would be the first part. So then what do you think this one means?
Centric?
What do you suppose that means? Do you see a word in there?
A model?
That's part of it. Kind of. We're close. Do you see a word?
Geo model?
Do you see a word in here that looks kind of like
Symmetric?
Earth-centered model.
centered? Yeah, that's what it means. Centered. So you get Earth at the center, right? So when you see geocentric, it means Earth at the center, right? That's exactly what it means. It's just two roots and we just stuff them together. That's what they do. It's kind of like when we think about compound words. Like here's a compound word, right? What is it?
Backpack.
Okay, and there's two words that make up this word.
Backpack.
So what does it mean?
Backpack.
A pack you wear
On your back.
on your back. Okay, how about,
Excuse me, Jenny, what
Yeah.
did you-
oh, Drew, did you bring the keys back to mine?
Oh, I thought you said there was on the side of the laundry room on the counter.
Oh, they're like laundry on the counter. He thought they were mine. Sorry. Okay, so what's that word?
Cupcake.
Cupcake. So what is it?
A cupcake.
It's a cake that's a little cup, right? All right. So we have geocentric. Very good. It's basically like a compound word. You can think of a lot of scientific words like compound words, but they're just different Latin roots and extensions. So that's what we have, and suffixes, prefixes, roots, extensions, all these things. Geocentric. So then, and this was who? Who thought this?
Earth.
Ptolemy?
Yeah, totally.
Okay. So what's this one?
Heliocentric.
Yeah, heliocentric. So anybody want to take a guess at what that means?
Helium?
Helium, okay. What do you think?
I don't know.
If we know what this means, okay, and we know what this whole word means, then what do we think helium?
The sun.
The sun.
The sun, perfect. That means sun-centered. All right. There are other words that have to do with the sun that include this root. So you're gonna, or this prefix. So you're gonna see it more. So this is just a really good thing. When you see words like that in science and you're like, oh my gosh, I'm never gonna remember that. What does that mean? That's all you have to do is just kind of, let me flip that up a little, break it down into its pieces. And a lot of it is gonna make more sense. And the more science you read, the more obvious some of it will become. And you'll be like, ah. So it'll start to make sense. All right, so you had Ptolemy, and then you had, who's the other dude?
Copernicus.
Copernicus. All right, Copernicus. That's the name of our fish over there. He's Copernicus.
Copernicus.
And has anybody seen Back to the Future? Like a gazillion times. All right, Doc has a dog named Einstein, right? But when Marty goes back to 1955 and goes to Doc's house,
From Rick and Morty?
no, Marty McFly in Back to the Future. When Marty goes back
Best movie ever.
and visits, I agree, and visits Doc in 1955, he has a dog that looks just like Einstein, but his name is Copernicus, right? All right. So Doc names his dogs, there you go, there's Marty McFly. So Doc names his dogs after scientists, all right? And I named my fish after scientists. Actually, every fish I've had since high school has been named after a scientist, except one. We did it in my AP biology class in high school. We had a whole tank full of fish, and we named them all after scientists, and that's what started my trend. Except for the little algae sucker, you know those Plecostomus? They're not very attractive looking. Have you seen them? They have those little mouths and they stuck to the glass. Have you seen them? They eat the algae. We named that one Little Richard because our teacher's name was Richard Bauer, so he was Little Richard. So all the others were scientists. Okay, don't ding too much, right? The two that I kept and took to college with me were was a black Moor named Watson, after Watson, who helped discover DNA, structure of DNA, and then a little white goldfish was the only one we'd given a female scientist name that year. We only had 5 or 6, and that was Marie after Marie Curie. It was really cool. All right, so our solar system consists of the sun, planets, moons. Oh, one more thing. There was a word I gave you. There was a word I gave you for these guys, for Copernicus and those like him that know knowledge in lots of different areas. Does anybody remember? Yeah.
Polymath.
Polymath. All right, that's another good one. How about this one? I love this. Polymath. Okay, so poly would be what? Does anybody know?
A name.
Poly.
Polygon.
Poly means many or multiple. Okay. So when you get into higher level math, you'll hear polynomials, which means many numbers, and there'll be all kinds of things. There's all kinds of stuff. And then math would be like knowledge, logic.
Yeah.
Logic. So lots of logic, lots of knowledge. There's polymath. Anybody know Hamilton well?
Yeah.
That word's in Hamilton. It's in, yeah?
What?
Have you caught it in there? It's in one of the Hamilton lyrics. Now you got to listen for it from now on. All right, so our solar system, it consists of the sun, their planets, and their moons, and a variety of smaller objects that mostly revolve in the same plane around the sun. Solar system's vast, right? That's what our lab is for. So how do we measure the solar system? What do we measure it in? Anybody know? Hand up. Go ahead.
Astronomical units.
Astronomical units. All right, that's your next blank. The blank at the bottom of the page on page 3 is astronomical unit.
Wait, you mean on page 4? Top of page 4?
Is it 4? It's 2 and 3 in mine. Yeah, it's 4 in yours then? Okay, because mine, my blanks are a different size than your blanks, so it doesn't always go to the same. I give you more room to write, and I type. So, and how do we abbreviate that? AU. All right, so that's what we abbreviate AU. Now with the lab today, we're actually going to be doing, we're scaling everything down. So what we're going to use is, we're going to use metric measurements for the lab because we're going to start down in the cul-de-sac and we're going to measure out our model of the solar system, and it's going to go up towards the main road. See how far we get. I know roughly how far we should end up, so let's hope we get it right. All right, and it says, we continue, it says that modern technology includes complex telescopes, piloted spacecraft, space probes, and that's how we're getting a lot of our information right now, right? And then, are there humans in space right now?
Yep.
Yep, where are they?
International Space
Yeah, International Space Station. That's where they are. Ding, ding. So that's where they are, right? They're in the International Space Station. And, whoops. And how do we...
I did this.
I know. Yeah, just stare at it instead of touching it. So how do we abbreviate the International Space Station? Sometimes it's called... Go ahead. ISS, yep. So if you go to that website that I listed there, you can get information on when it's coming. You can also use an app called Skywalk. If you've got a sibling in the older group, they probably have it because I required it for a lab last year. And it will tell you when the space station is going to fly over. It'll give you like a push notification. And you can go outside, and if it's a clear night, you can actually see it with your bare eyes. You don't need a telescope or binoculars or anything. It'll tell you where it's coming, like at whether it's coming south from the southeast or from the west, so you know which way to look. And then it'll give you like a kind of like a bearing. It's so and so many degrees or whatever, and you can watch it. Sometimes it goes kind of straight over like this. Sometimes you can see it go like that, but you can actually see it go by, and it's really cool.
Have you seen it?
Multiple times, multiple times.
Like blinking red light. Is it like a
No, it's not red. It looks like a little star. It's kind of whitish gold, but and that's because it's covered in solar panels, so it's reflecting the sun. Basically, it's a mirror, right? It looks like a mirror. Yeah. And it moves at a decent pace. Like you can watch it move. It's not like a shooting star that goes really fast. It moves at this nice, steady. I highly recommend at least once. We've done it. I've lost track of how many times we've done it. And there are certain times of year when it's passing over us frequently, and you can go out every night or multiple times a day. Like it goes over during the day, you just can't see it because there's too much light out there. It's not dark enough. But if you go out, at the right times of day, you might be able to catch it once in the morning and then once at night or whatever. It's really cool. So have you ever noticed the lumpy, bumpy appearance of the moon? Some people say it looks like cheese, right? So the moon has some very recognizable features that you can see with your naked eye or with low-powered magnifications like binoculars or a little telescope. So we got major surface features of the moon. Somebody ring or raise a hand and tell me one of them. All right, True, go first. Maria. And what are the Maria like?
It's like a black sea.
Yeah, like a flat part. That's another good one. All right, there's another one. I'm going to show you another one. It looks like Maria, right? All right, so Maria, this right here. Okay, how about this word? You know this word?
Like,
Marine. What's marine mean?
It's a military soldier.
Like a marine.
It can be a soldier. What else?
It's like the ocean.
No, the ocean, right? The sea. All right, there you go.
Maria
So what do you
is
suppose
also-
Maria means?
Sea.
Seas. Yeah, that's what it means. That's exactly what it means. So those dark patches are the Maria, and they're like seas. And one of them they call like Sea of Tranquility, you know, that kind of stuff. All right, wait, Trav was next. Tell me one of the others, Trav.
Crater.
Craters. All right, so the first one was Maria. The first blank was Maria. The third blank is going to be craters. Tell me about craters.
It's like a mountainy, like.
It's kind of like, well, the highlands are more like the mountainy part. The craters,
Islands.
yeah, the highlands are the one. So the craters look kind of like, let's see. So the craters kind of look, if this is the surface of the moon, right? There are these little, it's kind of like a little depression, like that. And it's like a little, usually it has a little rim around it. And that's because, why? What caused them? Do you know what caused them? What caused them? Not asteroids, but something a little smaller.
Rocks.
Rocks. What do you call rocks in space? Do you know?
Meteor.
Okay, very good. All right, so this is interesting. If the rock is here and it's flying through space, it's called a meteoroid. Okay? Meteoroid. Okay, but if this is Earth's surface and that same rock, forget the moon for a minute. If this is Earth's surface and that same rock is sitting here, we call it a meteorite. Now, here's the thing. Technically, the meteoroid isn't just the rock. It's the rock and the flames coming off the rock. It's the whole phenomenon, right? So the meteoroid is the phenomenon of the thing flying through the air. The meteorite is the actual rock, right? So same thing. You have meteoroids, all right? And they're zipping along, and here's your surface of the moon. And when they smack into it, it's like, you know, right? Boom. And it leaves a little, like a little hole. And then you get all these little hole-looking things all over the moon.
That's what she said.
And Drew, no. And those are the craters, right? We're not doing that in this class. All right, craters. So then what was the last thing? Not the craters, but what was the other thing? Wait a minute. Trav, what was the other thing you were talking about? Do you remember?
Island.
Highlands, that's the other thing. All right, so that one is a compound word that's an English compound word, right? What do you suppose that means? That's pretty easy.
A high piece of land.
Yeah, highlands, right? So those are the mountainous parts. All right, does anybody know, or did you read, what do we think caused the moon to form? Drew.
Well, you got the answer that you said, or the answer that you showed me on the documentary.
Why don't you take the one from the notes, and then why don't you share both?
So the one from the documentary you showed me was, well, what Will Smith said.
Will Smith said, yeah, it's called One Strange Rock, totally worth watching.
The Earth had a twin or another planet forming just like it, right next to it, and since two things have gravity in between them both, they smacked into each other and then took like a massive chunk out of Earth,
Mm-hmm.
and then the other planet just kind of like exploded.
Yeah, so so that's basically the idea. So the idea is that you've got Earth, okay?
Something whacked into it.
Yeah, you've got Earth, and then you have some other body, which very well may have been like a binary system and another mass, because Earth was still forming, right? And whatever this was, due to the gravity, gets smacked into Earth, right? And then like a big chunk of Earth breaks off. And so what happens in space, like, okay, the planets are round. Well, why are they round? All right. It has to do, they're flat earthers. It has to do with the fact that when things start spinning, which is what happens when you got enough gravity, things will start to spin, right? They spin and they spin and they spin, and everything gets sucked to the middle. It's kind of like, I don't know if you've ever done it, and we may end up doing it, I think, this year. I want to say it's one of our labs or something similar. But if you ever sit in a chair that's just like an office chair, the spinny kind, and you just sit there and let somebody spin you, and then you tuck your legs up and make yourself smaller, you spin really fast. Like, you can do it on a swing too. Like if you have a regular swing,
Oh, okay.
you can spin it up, right? And you can sit on it and just spin. And then if you tuck yourself in, you'll spin like really fast.
Okay, so
Mhm.
I was at my friend's house and Traveler was there because we had a cookout. They
Uh-huh.
had this big spiders swing.
Oh, those are great. Yeah.
And they hooked it up to,
It's like a net thing that you
Yeah.
get in. Uh-huh.
and they hooked it up with some metal wire,
Mhm.
and we twisted it up, and we laid out our legs flat, and then we tried to tuck them in.
Right.
And with all that force
Mm-hmm.
was holding it back. So
Right.
when we finally tucked it in, we were going even faster.
Yeah.
Which I was like,
It's incredible, isn't it? Yeah. That's physics for you, right?
we're gonna hurl!
So that's
I'm gonna hurl!
So that's how our planets form like that. And well, the idea is that the Earth and the Moon did the same thing. The mass that made the Moon is spinning around and it forms itself here, and the mass that's making the Earth forms itself here. Now, the Earth and the Moon are gravitationally connected, right? Now, here's an interesting thing. Have you ever put anything at the end of a string and spun it around? Okay, where does it want to go? It wants to go out because it's spinning, right? It's orbiting you. Basically, it wants to fly away. So the Moon wants to fly away, but it can't because it's being pulled to the Earth by gravity. So the fact that the Moon's being pulled in and it wants to go away at the same time is what keeps it right where it needs to be. Now the Moon's orbital path around the Earth isn't round, it's elliptical, and most of the solar system have elliptical orbits. So an ellipse is a shape. So this is a circle, right? Okay, so this is an ellipse. It's like a elongated circle. So if you have the Earth here, kind of like an ellipse, if you have the Earth here, the Moon doesn't do that, okay? It doesn't go around it like that. It goes around it kind of like this, and it's actually not quite even, right? It's sort of longer in places and shorter in places. And so this has to do with like how close the Moon is, has to do a lot with how big it looks, and also has to do with tides. Do you know the Moon's connected to the tides?
Yeah.
Yes.
So if the Moon is closer to the Earth, so, okay, here's your Earth, all right? And here's your water on Earth, all right? If the Moon is way up here, actually, I'm gonna make Earth round, because it's round, you know.
Not flat.
All right.
Not a cube like in Minecraft.
Round enough, there you go, yeah. So if the Moon's way far from the Earth, then down here, like it's nowhere near this side of the Earth, right? Okay, so this water is kind of low. And why it's lower is because where is it closer to? It's closer to here, right? It's not close to this side. So what happens to this water is the Moon's pulling on Earth and it pulls the water. So you get higher tides on this side, and this side is lower tides because the water's all connected, right? So it actually sucks the water that direction.
Is that why like waves are bigger?
Winds?
Waves.
Waves. Can be, yeah, because the Moon's now kind of towards your side, but the Moon's out during the day sometimes and you can't see it.
I can.
Yeah, it depends. So it really has more to do with, yeah, how close it is to you. And there are times when you've got the Moon really close and you got a high tide, and when the Moon's not close to your part of the Earth at all, it's a low tide because it just kind of sucks the water one way or another.
I heard that the moon is moving further and further every year. Is that true?
Probably, yeah, a little bit.
In a couple of billion years, we'll never be able to see the moon.
Well, by then everything will be all jacked up. So,
Did you hear
We'll be able to
hurricane?
yes, the hurricane. Yeah,
5 people
Dorian.
have already died.
Yeah, Dorian's a big old deal. Yeah, we'll probably chat about that.
57 have died from boats.
I believe it. It's crazy. It's
I saw it
crazy.
on the news.
Will the
when I was
moon have
in
an effect on a
September.
hurricane? Well, like that.
Yeah, the Moon can, because if the Moon's closer and it's a higher tide, it's more water for the hurricane to suck up and it's more water to flood. So, like, that's kind of a perfect storm situation, literally a perfect storm situation. Unless you're in it, then it's totally not a great storm.
And
Yeah.
like in 20 million years, we'll be able to go past the Milky Way galaxy. So we don't need the moon
We're
anymore.
We're gonna need to be out of here by then anyway, because if we lose the sun, we're done. And you know the sun's a
15
star.
million years. That was
Yeah.
15 million years. We would have been dead for that.
So the sun's a star, right? And
Milky Way galaxy.
the sun is just like all stars. It has a life, right? It's gonna die like all other stars, and they figure it's about halfway through its lifespan. So if you think about, we talked last week about geologic time, right? And how many? Remember that football field? Okay, way long ago, and remember, like, humanity was in this last little tiny inch or something of the football field, itty bitty bit. We have a whole other football field to go before the sun does what stars do. And what do stars do when they die? Boom. Yeah, right. So
And then the earth would freeze and all life would be dead, except for vampires. They don't need.
except for vampires. Well, if the sun
Vampires.
explodes, it's gonna burn. Like, we're close enough to get fricasseed, so we'll be done. We'll be done, but we won't be here. None of us will be here.
Bite me.
Yep. So let's finish this up real quick. So-
Actually, a night planet.
Well, they keep changing their mind about Pluto, but Pluto's been a
No,
dwarf
no,
planet for a
no.
while. Oh yeah, you were talking about they saw something else that they're considering. Yeah.
There's a ninth planet.
I don't think they've officially considered it. They're discussing it. Then we'll have to
If
watch.
I see a new planet, I'm naming it Eleanor.
Eleanor's planet.
Eleanor's Amazing World.
There you go. Well, we got about 9 minutes left. So it talks about eclipses, and there's a good graphic there. Oh wait, the apparent changes in the shape of the moon are called phases, right? And that's how we look at the moon. The moon doesn't really change shape, right? It's just how it appears, which that's what the word apparent means, right? And it has to do with how much sunlight's hitting the moon and from what angle we're looking at it. All right. So then, like last night, the moon was a little fingernail sliver, but the night before it was even a smaller sliver. And when the moon is getting bigger, apparently appears to be getting bigger, that's called waxing. And then when it appears to be getting smaller, it's called waning. So it's waxing at the moment.
Yeah.
So if you looked at it last night, look at it again tonight, it'll be bigger.
Isn't a whole week when it goes all the way around?
It's a month, about a month. That's why our months are 30 days long, 28 to 31, whatever, because it's based on the moon cycles. So, okay, let's see. So you have an eclipse is when one celestial body casts its shadow on another, and a solar eclipse occurs when the moon casts a shadow on a portion of the Earth's surface. A lunar eclipse is when the Earth casts a shadow on the moon. Now, we had the solar eclipse 2 years ago. Did anyone go and see it? It was the most amazing thing I've
I went
ever
to
seen.
Nowhere.
Did you? Yeah, nowhere. We went
There was
to,
actually a place called Nowhere
really?
that we went to.
I have to go.
That's
we went to,
And they had, like,
Takoa. It was
they-
amazing.
They had like
Very
a
good.
cookie that was like a moon face.
Oh, the moon phase.
It has to be going somewhere.
Yeah, it was without a doubt the most amazing thing I've ever seen in my life. It was incredible. And my husband got amazing pictures. It was so cool. We had family that came up from Virginia because they weren't going to get anywhere near the amount of coverage we were going to get. And so my father-in-law said, if I'm coming down from Virginia, we're not staying at your house. We're going somewhere I want totality. So we did. We went up to Takoa, and it was cool. All right, so I'm going to read this last bit on the solar system to you, okay? And then when we get outside, you guys are going to have some jobs to do to construct this model for us.
You mean the solar system part?
So the solar system. So we discussed earlier that the solar system is vast, and the planets nearest the sun are called terrestrial planets because they have a structure much like Earth. They have the crust, mantle, and core. We talked about that last week, right?
Can you turn down the air a little bit?
Yeah, I'll try to turn it down a little bit. Oh, you mean you're cold? Oh, we're going outside in 5 minutes. You won't be cold then. So I have it cranked down because there's so many people. Hang on, Drew. Let me go through this page real quick, and then we'll do that. So what's the planet that's closest to the sun?
Mercury.
Wait, hand up. Mercury. Very good. All right, Mercury is closest to the sun. And then what's the next one?
Venus.
Venus. And what's next?
Earth.
Yep, our third rock from the sun. And then what's next? Lily.
Jupiter.
Not Jupiter.
Mars.
Mars. Okay. Mercury, Venus, Earth, Mars. Okay. What comes after Mars?
Asteroid belt.
Jackson's hand was up. Okay. Asteroid belt. Okay. So we get this big old belt of rocks, right? Whipping around in the middle. That's pretty darn cool. All right. Now, hey, Sky. Here you go.
Dwayne Johnson is just spinning around.
Yeah, the rock.
Yeah.
There you go.
Their face is like.
So the asteroids are in the asteroid belt. Okay, scientists now hypothesize that asteroids are remnants of the early solar system that never came together to form a planet. They're just sitting out there spinning. So you look like you're ready for the next one. Lily, what's after asteroids? Say it. Jupiter. Okay, so what's our largest planet? Jupiter. Okay, and what's the defining characteristic of Jupiter when you look at it? Do you know? It's a gas giant, which means
It's got a big giant circle.
it's got a circle on it. What is that called?
The Great Red Circle.
The Great Red Spot. Yep.
Great Red Spot.
Very good. What is it?
It's
Do you know?
It's a storm.
It's a storm. It's a never-ending, eternal, giant red storm that never stops. It just
We
keeps
thought
going.
Dorian was bad.
Right. Yeah, good thing nobody lives on Jupiter. So these gas giants are composed mostly of helium and hydrogen, which interestingly is what the sun is composed of, right?
Jupiter.
So you got Jupiter, and then what comes after Jupiter? Trev.
Saturn.
Saturn. What's the defining characteristic of Saturn?
It's rings.
It's rings, right? It's got these amazing big rings that
Flat
circle around it. Yeah, they're flat. Yeah, it's very cool.
And they're very thin and they're very cool if you go on them.
Okay. Now here's one. Here's one. This is the next planet. Okay.
Uranus.
Okay.
Uranus.
It's, this is the one everybody loves to say because you can sound somewhat dirty when you say it. It's Uranus. That's the way to say it. So nope. It's that's the accent. Uranus. And that's how you say it. Although saying Uranus sounds funny, so everybody says it. And what's the interesting thing about Uranus?
It
It's
has
on the side.
It's tilted and
it has rings, but they're smaller.
it has rings, but they're smaller. So here's the thing. If you were looking at it in the same plane, okay, now three-dimensional, you could be anywhere you wanted. But if you were looking at it in the same plane, Saturn's rings do this, right? Uranus is tilted, and its rings go like that. Like it's sideways, kind of. So like last year, what we did is the kids had to do a travel advertisement for anything we had studied. So some of them did some geologic features, some of them did planets.
Yeah.
So Cole did Uranus, and he titled the brochure "Get Tilted," which I thought was cool.
Tilted tower.
And what's our last planet? Neptune. And what color is Neptune?
There's a planet.
Blue, right. Okay, it's blue because of the type of gas. What's the gas that's in Neptune's? Methane. Okay.
Then there's
Do we get methane on Earth?
No.
Yeah, we get methane on Earth. Do you know what do you know what's a really big source of methane? Do you know? Cow farts. Just say it. Yep. Cow gas produces methane. Absolutely, it sure does.
Can I say a fun fact?
Yeah, hang on one second. We'll come right back to you. So then we have this last little paragraph here, and then we're going to read this bit about sun real quick. So the nebula theory states that the solar system formed during a rotating cloud of dust and gas. That's what we talked about, like rotating and getting condensed. And then this last bit about sun and stars real quick. Okay, so the sun, how the energy is produced by fusion. So basically what you get is two hydrogen nuclei that turn into a helium nuclei. You have a periodic table in here somewhere. I swear you do. Is it in the back? Yeah. You have a periodic table in there. Mine's going to be in a different place than yours. But if you look at it, the first element on the periodic table is hydrogen, which means it's the smallest number of protons. And when you combine, here it is. Here's mine. Well, it looks like this. So here's hydrogen. See, it's number 1. And then here's helium. It's number 2. And 1 plus 1 is 2. So it's on 3 in the resources. For me, it's in the front. So it's up in the very, very front. So that's what happens in the sun. The fusion, the joining together of 2 hydrogen nuclei to form a helium nuclei is how the sun produces its energy. It's called nuclear fusion. That's what happens there. So the sun's interior consists of the core, radiation zone, convection zone.
3 of resources in the
Yep, 3. It was 3 in mine too.
Oh, it's 2.
So stars are categorized by their color, size, and brightness, okay? And there's this really cool thing called a, whoops, it just went out of my head.
This is the periodic table.
There you go. Yeah. I can't remember what it's called. Oh, it just went right out of my head. There's a diagram, a type of
Are
diagram.
you gonna grade the?
I'll grade them. So it's in their section, so I'll look it up. But basically, it puts the stars on a big, there it is, Hertzsprung-Russell diagram. Could not remember the name. It's a diagram, and it takes all the stars that we know of, and it plots them basically by size and color. And you can see which ones are the big ones because they stick out here on the corners. Most stars are right kind of in the middle. All right. Let's see. As star forms, we talked about that. Okay, galaxy. So what do you call a galaxy? A galaxy is a group of stars, star systems, and star clusters, and it's all bound together by gravity. And there's different types of galaxies. If you look in the picture, see the pictures where it says types of galaxies is page 6, I think, of your lesson.
Spiral, barrel.
Spiral, barred spiral, yep. And elliptical and irregular. So what's the name of our galaxy?
Spiral.
No, the name of our galaxy. Milky Way. And what kind is it?
Spiral.
It's a barred spiral.
Yeah.
Barred spiral. So, yep, so look.
Milky Way is awesome.
No, it isn't.
It is.
I don't
So-
understand why it's called Milky Way.
Because it looks white, like milk, I guess. So you have elliptical, and that's when you just kind of have, you have all these stars, and they're sort of in a disc shape, but they're not doing anything. Yep. Then you have the spiral, and that's when they do like this, right? They spiral around, and there's usually some
Satisfying.
outliers, right? That kind of come out like this. Then you have a barred spiral. Okay, that's when the middle's kind of tight. That's what we have, right? And then it kind of goes this way. And then you have these little trailing ends that kind of come like this, right? Like that. That's what ours looks like. And then the last one, the irregular, is just like, we don't know what we want to do yet. We're kind of a blob of stars. And if you look at that picture of the Milky Way and it says you are here, you are barely there, right? Like you are tiny, 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 tiny. All right, what did you want to say real quick?
I was gonna say, did you know they used to make glue out of horses' hooves?
I did. It's kind of gross, but yeah, I did. That's a weird fun fact for today.
What if you had two dogs?
I don't. The little brown one, this one says Otto. He's my mom's, and she's at a doctor's appointment, so he's just chilling because he can't be without people.
That makes sense. I thought you had two dogs.
So somebody tell me real quick, what are our 4 terrestrial planets?
Mercury, Venus, Earth, Mars.
Very good. Okay, what are the 4 gas giants are?
Jupiter,
Hang
Jupiter,
Uranus.
Neptune, Saturn,
Uranus.
Uranus.
Okay, now Pluto. Pluto's this weird little thing, right? Okay. Pluto is technically what they're calling now I don't know why it was on my thing,
I feel bad
a
for
dwarf
Pluto.
planet. They used to, when I was in school, we had 9 planets. And now, we don't. Pluto has been kicked off the planet roster
Poor Pluto.
I know it stinks for Pluto.
He's not even getting mentioned on Mickey and the Ghost of Racers anymore. He's not having it.
He's done. He's very, very done. All right, so does anybody know what was the phase of the moon? Does anybody remember what you wrote for that? Hang on. Shh, shh, shh. Does anybody remember what the phase of the moon was? Did anybody look that up and remember it? Do you remember?
I'm pretty sure it's the waxing. Yeah.
Yeah, it should be waxing crescent. I didn't even look it up, but after looking at it last night, that's what it was. It's definitely waxing. All right, so we're gonna head to lab, and
Outside.
which is outside, but we're gonna gather up in here first because I'm gonna go over instructions. Make sure everybody understands. Does anybody have any questions about this lesson?
Do we need
To go outside? Probably not. You may need a little scratch paper or something, but we're gonna, there's no write-up for this, but this is gonna be, you're gonna need some information written down. I'll bring scratch paper if we need it. Question?
Why are we going outside for the lab?
Because it's huge. Question?
Yay.
No? Question?
I have a statement.
Question? Hang on.
Where's my lab?
Are you gonna?
It's nothing there.
Are you gonna? Are you
That's all. See that right there? That's it.
Are you
Yes. Hang on, wait.
Could I make a statement?
Real quick.
Actually, Planet 9, I
Mhm.
forgot what it's called, but if you were to do a football field reference,
Yeah.
it's actually 7 football fields away from Earth.
Wow. And this is the one that they're looking at and considering. Yeah, I did see about it, but they haven't like officially named it or.
It's just crazy that
Mhm.
something that we made can go comparative to the top of a push pin being Earth. of how far away.
Yeah.
Central Park is.
Y'all two real quick, and then we got to get going with everybody else. Go ahead, Delia.
For the theme of Rico, was it alien or astronaut?
Yeah.
It was Alien, but if you did Astronaut, it was really good.
I did too. My mom gave me. She printed out.
Okay, that's
another
fine.
book.
You stapled them too.
I stapled it.
All right, so you may want to take that piece of paper that's your lab, it's just that one piece, just so you have something to write notes on and a pencil. You don't need your binder or your book or anything like that.
Can I have scratch?
Hold on, wait a minute. I would also put your name on it immediately, so you don't put it down and then not know whose is whose. All right, are we good? Jack had a question?
So you said on email there was something wrong in the notes or lessons.
Yes, Delia found it. It was on the test. There was a type. Well, it was like the notes. Yeah, the notes were wrong, which confused the test. And it was this diagram that was right.
Oh, yeah.
Show you. I didn't even notice, but Delia caught it. The diagram had a big mistake in it. This right here, I didn't even see it. This right here, the asthenosphere and mesosphere were flip-flopped. So if you got that answer flip-flopped, don't worry about it.
Yeah.
Flip. No, lesson 4. Flip the other way. You need a pencil and that piece of paper. All right, I'm gonna.
What? I can't find it.
Okay, I'll help you.
Also, can I go outside